A manometer contains a liquid of density 5.44 grams per centimeter cube and is attached to a flask containing gas A as follows. If the same liquid is used in a barometer to measure the atmospheric pressure, then what will be the length of the liquid column which exerts a pressure equal to 1 atm? Density of mercury is 13.6 grams per centimeter. So, if you remember, what a barometer looks like is this. It has a test tube on the top and mercury inside. The pressure exerted by the atmosphere here is showcased by the height of the mercury column here. And for that, we use the equilibrium equation that P atm is equal to rho of mercury into G into the height risen by mercury. And similarly, if we use this barometer for this particular liquid, it would be the density of the liquid into G into the height risen by the liquid. So let's put in the known values into our expression. Density of mercury is 13.6 into G into the height risen by mercury, we know for 1 atm is 760 mm, or since everything is in centimeters, we could also have written a 76 here. The density of the liquid is given to be 5.44, right, into G into the height risen by the liquid. So this G gets cancelled out. We are left with a 13.6 into 760 divided by 5.44, and this gives us a 1900 mm. Or this can be written as 190 centimeters. So the answer for this part becomes option A. Okay. Now remember that the pressure exerted by this liquid column is corresponding to 38 centimeters. Okay. Now in the previous part, we've solved that 190 centimeter would imply 1 atm, right? So what we have here is 38 centimeters. So what would 38 centimeters correspond to? They would correspond to 1 divided by 190 into 38. This gets cancelled by 19, giving a 2, and this gives us 0.2 atm. So the pressure by the liquid column is 0.2 atm, and that exerted by the air above is 1 atm. So the total pressure comes out to be 1.2 atm, right? And our answer becomes option D. If A undergoes 30% trimerization, 3A forms A3. Then the difference in height of the liquid level in the two columns is. So we have 3A forming A3. Let's write it as A forming 1 by 3 A3, right? So initially A was at a pressure 1.2 atm. Now if there is 30% trimerization, it would mean that the A left is 1.2 minus 0.3 times 1.2, and the A3 formed will be 1/3 of 0.3 times 1.2, right? So on the left hand side, we are left with 1.2 minus 0.36, and on the right hand side, we have 0.12 atm for A3. So the total pressure comes out to become 0.96 atm. Okay. Now 0.96 atm is the pressure inside the flask, and the pressure of the atmosphere is 1 atm. So the difference is 0.04 atm, and this difference will be catered by that height in the manometer, that is the height of the liquid risen. So for 1 atm, the liquid rose 190 centimeters. So for 0.04 atm, it would rise 190 into 0.04. This 190 came from solving of the previous part. And on solving this, we get 7.6 centimeters. So the height risen in the container would be 7.6 centimeters of the new liquid. That is option B.